Same thing, I'll just do number 3 and stop if there's anything that needs to be mentioned. Okay, to get the true length of AB, let me draw this out just now as a rectangular prism. Here is a rectangular prism. Down here, there is point B, sitting on the bottom in that location. I know I've got going from point B to point A. In true length looks like that. So let's just draw in the rest of the rectangle. So I've got a spot up there. Essentially to do the maths, I've got that. So I've got to go down that distance, I've got to go across that distance, gives me one triangle. I've got to go across there, get two triangles to calculate the true length. How you do it is like this. This is going to be about as hard as it ever gets in any HSC ever. I just drop that down like so. Let me just get it accurate. Drop that down like so. That's that far down. That's that far down. Okay, there's a slight misalignment in these two lines is the issue. That's fine. So now I've actually got the baseline accurate now. Pitch down to about here. I'll split the diff. I'll say it's there. Now I have the baseline. I'm going to pitch it back up. So that's from point A to point B, lies somewhere on there. Point E to point F is true length on this drawing. So that is true length of EF. So we've got EF, it's somewhere on there. We've got AB, it's somewhere on there. Now we've got to repeat what we did earlier. I'm looking for the pencil eraser. There it is. Just to avoid confusing things, we've got to repeat what we did just a little while back for these guys. EF we've measured. Now we need to get E to B. We know that's the horizontal distance from E to B. That's actually measured. I won't bother redoing that. That's E to B. Vertical distance is almost a straight line. So, within limits of error, E is vertically above B. Technically there is a difference in the length. E to B is just a fact. There you go. So that's the true length E to B, or good enough. E to B. Okay. So there's A to F. I've just pitched that down to vertically straight underneath it. Now I'm going to measure off that intersection point back out to A. This is actually some fairly complex geometry. So that's A to F is there. And there they are. So there's point F. We'll just check this in a second. A to D to A to B. So B to F is approximately a little bit bigger than 67 mil. There you go, I'll go with that. F to G is true length. B to C is true length. Okay, back to it. So we've got EF, AB, we've got that face drawn, so we've got that top face drawn, we've got that face drawn, now we're working on the underneath. So point G lies somewhere on that mark, point C lies somewhere on that mark, E to F, sorry, is a true line, F to G is a true line. Now we're looking at G to B to calculate G to B. From there to there, from there to there. G to B goes once again in two directions. G goes there. So point B to point G lies there. Similarly, point F to point C is the same dimension, lies there. Just check that B to C is exactly 43 mil apart. B to C is 43. Now I'll just finish up with the last one. Which is a duplicate of this beastie. Distance A to B is the same as distance C to D. So distance A to B is there, distance E to F is there. There's distance A to F, there's distance A to F is out there, A to F is the same as distance D to G. A to F is D to G. So there's point D, and similarly E to B. E to E, F, G, H, A, B, C, D. C to H is the same as B to E. B to E, okay. C to H, just there. So there's the third one done.